a literal equation. In order to solve this literal equation, we still want to get all the terms that contain the variable we're solving for, in this case y, on one side, everything else over on the other. I've got an ay over here, I've got a negative by over here, I'm going to bring the negative by over here, I'm going to add by to both sides. I'm going to add by here, I'm going to add by here. So I've got ay plus by minus bz is equal to az. Everybody okay? And you cannot add ay and by. They're different terms. Okay? They're not like terms. In order to get this isolated, I need to get rid of the negative bz. In order to do that, I'm going to add bz here. I'm going to add bz here. Now, I have ay plus by is equal to az plus bz. Right? So I've accomplished what I wanted to accomplish. That is, I have all of my variable terms on the same side. Now, what we have to do is go back to what you did in chapter 1.3. Here, we've got to do a little factoring. I'm going to take out my greatest common factor. My greatest common factor here is y. When I factor out a y, I'm left with a plus b. Over here, my greatest common factor is z. When I factor out a z, I'm left with a plus b. Is everybody good? Now, once again, something we've been talking about all along. I need now to go ahead and divide both sides by the coefficient of the variable, which is the term by which the variable is being multiplied. Y is being multiplied by the quantity a plus b, so that is my coefficient. That's what I'm dividing both sides by. When I do that, go on here, here, and I get y is equal to z, and that is the answer to that particular literal equation. But once again, it all comes down to procedure. This is the exact same procedure that we used on every single equation so far. It's the procedure that's very, very important.